Our last presenter in this session is Julia Boenchendorf. I'm sorry for pronouncing that incorrectly. But Julia's going to be talking to us about bovine tuberculosis in cattle and red deer in Southern Bavaria, Germany. Can network analysis explain the routes of transmission? Thanks, Julia.
Thank you for this introduction, and thank you for the opportunity to present some results of my doctoral thesis today. Just to give you some background information, because it's very different, the situation in Bavaria to the situation in Ireland that we heard so much about already. So since 2004, there was an increasing number of TB outbreaks in cattle in Southern Bavaria. And there are three important differences that I'd like to underline in comparison to the situation in Ireland, for example. First, the causative agent is not the same. It's not M. bovis, it's M. capri in Bavaria. Second, it's not the badger, who is the most important wildlife host species, but red deer. And third, we had a period of relative quiet regarding bovine TB before these outbreaks. So back to our study, the transmission between cattle and red deer has been described in regions close to the border between Germany and Austria. And as the most probable location of this transmission, cattle to cattle and cattle to deer, alpine summer pastures have been discussed. So to give you an idea of alpine summer pasturing, I brought you this picture. And that shows a typical alpine summer pasture, little fences, and there are a lot of cattle from different holdings being sent up high into the Alps to graze there and to give the farmer in the valley time for making hay at the same time. So cattle from many different holdings and from different herds can mix and mingle there with each other, but also with red deer. Perfect for disease transmission, as you might imagine. So now there you see our study area on this map. That is the Bavarian districts close to the Alps in the very south of Bavaria. Now, the aim of our study was to evaluate the respective importance of several possible transmission paths. First, TB spread via cattle-to-cattle contact, cattle trade, but also to evaluate the importance of alpine pasturing for disease spread and the role of cattle-to-deer contact. Our study period stretched from 2010 to 2014, and our cattle data originated from the German cattle database and included movement data and data on TB test results. The data on red deer came from several European and Bavarian research projects and included the hunting sites of 63 TB-positive red deer. So for our study, we selected two groups of interest in cattle. So to be considered as positive, the animals had to have at least one positive test result in any testing method, including premortal tests of limited specificity, as you all know. For example, we used, or in the region, they used the gamma interferon assay and the tuberculin skin tests. To be considered as confirmed positive, the animals had to have at least one positive test result in a post-mortem test as well. So, per definition, the group of confirmed positive animals would be a subset of the positive animals. Now, I brought you two example networks. The left one is the contact network, with the circles being the nodes, and those nodes correspond to cattle. Whenever those nodes are linked by an edge, that means that those two animals had direct contact in a holding, which means that they stayed at one holding at the same time. On the right-hand side, you see the trade network with the nodes having the form of squares. So they correspond to holdings, and the edges between them are directed because they represent cattle movements. We'll talk about the coloring when we look at the actual networks in a minute. Now, the questions we had in mind for our network analysis was, can we explain all the TB infections by the contacts and movements of tested and positive cattle? And do positive cattle holdings and alpine summer pastures have a special or more central network position? Now we get to see at the we get to see the results. First, that is our contact network. Try not to be shocked at a typical network graph explosion of colors and all. I'll just point out the most important details to you for lack of time today. So those nodes you see, the coloring is given by their status of infection. So the nodes are cattle, light red positive cattle, and dark red confirmed positive cattle. And the edges between them represent the contacts, direct cattle-to-cattle contacts. Now, the most important thing about this graph is the share of edges that's colored green, because that is the share of positive cattle that only met on alpine summer pastures, which is quite a big share, as you see. And the most important second aspect of this graph is that there's also a lot of isolated nodes at the margins of the graph. In the middle, you see one giant component linking lots of positive cattle by direct cattle-to-cattle contacts, but not all. The situation is similar in the trade network. So this time, the nodes correspond to holdings, and the edges between them are directed, so they represent cattle movements. Coloring is the same, so light red for positive holdings and dark red for confirmed positive holdings. In the background, you see all the movements in gray by animals that are either not tested or had negative test results. And highlighted in the front, you see the movements of positive cattle in light blue and of confirmed positive cattle, dark blue. So you see that there's one giant component of positive and confirmed positive holdings that is linked by the movements of positive cattle. But there are also some holdings at the margins of the network where you don't really see that positive cattle have moved between them and others. Now we get to another aspect of network analysis, that is the calculation of centrality parameters. One of the most widely used centrality parameters is the so-called unweighted in degree. That corresponds to the number of farms another farm receives cattle from. So we wanted to know if positive holdings have higher in degree values, meaning they have a higher number of ingoing cattle contacts. To compare those positive holdings to holdings without any positive test results, we performed a kernel density estimation of the distribution of the unweighted in degree. And as you can see, the farms with positive and confirmed positive animals and test results have higher median values for the in degree than the farms with only negative test results. Now that our network analysis already pointed into that direction, we decided to get a closer look at the alpine pastures. And we wanted to know here, do holdings with positive TB test results have more frequently trade contact with alpine pastures? Therefore, we aggregated the farms by status of infection. So on the left side, that is the category of farms that were not tested for TB at all. Then farms with negative only test results, with questionable positive and confirmed positive test results. The y-axis, and therefore the height of the columns, corresponds to the number of farms per category. And the width of the green columns corresponds to the proportion of farms per category that had trade contact with alpine summer pastures. So there you see that farms with positive and confirmed positive TB test results send animals to alpine summer pastures much more often than the rest of the farms. Last, we wanted to identify risk factors for the occurrence of positive TB test results in holdings. Therefore, we performed logistic regression analysis. Anybody interested in details, just ask me later. Interestingly, the size did not have a significant influence on the risk for positive TB test results, but the geographic location did. So farms located in the very south of our study area, in the districts Oberallgäu and Kempten, had a significantly higher risk for the occurrence of TB test results that were positive, as well as ingoing cattle movements from alpine pastures, but only from alpine pastures, not from markets or any other holding type, increased the risk for TB test results that were positive significantly. So you probably realize that the most important and interesting test result of our study is not the proportion of holdings and cattle that were linked by contacts and movements of positive cattle, but those that were not linked, because there has to be some unknown component linking the rest of the cases. And I have a lot of theories about that. I just wanted to show you one funny geographic coincidence. On this map you see, represented by the red coloring, the number of alpine summer pastures that had grazed confirmed positive cattle during our study period. So that is concentrated in the very south of the region of Allgäu. So that is the region of Allgäu on the left of the map, and that is the region of Upper Bavaria. And there you see that there's a funny coincidence of those districts with alpine summer pastures grazing confirmed positive cattle, and of the TB cases in red deer, colored in yellow. And that is not the case on the right side of the map. So for Upper Bavaria, you see that there's only a TB hotspot for red deer, but the confirmed positive cattle in that area were not sent to alpine summer pastures in this area, which is pretty interesting. So there seems to be some link, and there doesn't. So to conclude, we saw that a large extent of infection patterns could be explained by network patterns, but not all of them. Unfortunately, we did not have sufficient data to really explain any routes of transmission between cattle and red deer, or let alone to perform a network analysis, including both species. And the second important finding was that alpine pasturing seems to have played an important role for the spread of TB in Bavaria. So last, I want to thank all my research partners and the Bavarian Ministry of Agriculture for the funding of the study, and you for your attention. Thank you.
Excellent. Thanks very much, Julia. Are there any questions? If I can then as chairman. So from your analysis, was there any evidence of something like a super shedder animal who would spread disease around when he's up in the mountains grazing?
Yeah, there were several animals where you could more or less trace how they came home from the pastures and went through different holdings. Now you could see some trace of TB going there.
Okay.
Yeah.
Excellent. Everyone's hungry, are they? Oh, no. Teresa.
Just one question. How do red deer on alpine pasture interact with cattle? Are they happy to graze alongside cattle, or is it that they've, left infection behind them before the cattle arrived?
That is a very good question, and there's much work to be done on that area because we don't really know that. There are photos where you can really see them interacting, like grazing side by side or sleeping on the same pastures, but I think it's really more the indirect contacts that transmit the disease.
Okay, well, if there are no further questions, I'd like to thank all our speakers today for such wonderful talks and for keeping to time so well, and for everyone in the audience for their attention. So thanks very much again, and enjoy lunch.